All right, this is lesson 2.3, Pre-Algebra, simplifying variable expressions. All right, so here's some things you need to understand. If I have this, each one of these things, each one of these is a term. Terms are products, is the number or the product of a number and a variable. If you see a number, like if I just have the number 5, that's a term. If I have the number 6m, that's a term. If I have 6xy, that's a term. Okay? Terms are separated. If each term is separated with a plus or a minus sign. Okay? Each one of these is a term. They each have their own sign. They're each either positive or they're each either negative. This one is obviously, this one here is obviously positive, and this one here is negative. This one's positive. What's this one? It doesn't have its own sign. What is it? It's positive. If there's no negative sign, then it's assumed that it's positive, right? There's an invisible plus sign right there in front of it, right? Each one is its own term. Okay? Another term that you're going to need to know, another word that you need to know, is that if I have this 2x plus 4, how many terms are there here? There are 2 terms, one here, one here. This is a special term called a constant because it is a number only, no variable. It's called a constant. All right? It's called a constant. All right. Here's the deal. Like terms, I'm going to go back to this. This right here, all of these guys, all of them, they have what's called like terms. The variables in each one of these are identical. They're identical. Each one of them has an x, right? They each have just an x. Since that's true, they all have what's called is like terms. If one of them, if it was to be, 2x plus 3xy plus 4x, there's a term, there's a term, there's a term, a little invisible plus sign there, right? Is that identical to that? No, there's a y there. They're not identical. Therefore, they are not like terms. What about 2x and 3xy? Are they like terms? This and this are like terms? No. Okay. What about this? What about 2x and 4x? Those are like terms. Here's the deal about like terms. You are allowed to combine like terms. On your paper, I want you to do this. When you have it like this, I want you to draw these circles here. I want you to draw the circles. I want you to see that everybody has their own little sign in front of each one. Then you can combine the terms that are alike. So I can go 2x, and then and I'm adding a plus 4x. What is 2x plus 4x? That's 6x, and they're gone now. And that leaves me with plus 3xy. Does that make sense? I combined the like terms. I cannot add or subtract the terms together unless they are. I cannot add or subtract. Can I combine those two? Can I combine these two right here? Of course not, because this term and this term are not identical. This is just an x, and this has an x and a y. They're not identical. They're not identical. You cannot combine them. Does that make sense? If I have 2y minus 3x plus 7y, you got to go grab each term, right? I want each term to have its own sign. The front one you don't have to do because there's just an invisible plus sign there. You grab each term. Now you're going to combine the ones that have like terms. Like terms means identical. So that would be, I can add the 2y and the 7y, which makes 9y, and then I have minus 3x. Can I combine 9y minus 3x? No, they're not like terms, right? Okay, what about this then? What if I have 5 minus 4m plus 6 minus 3m? What do I need to do here to start this whole thing? Circle them. Give them each a term. Make sure that you understand that each one has its own sign. Now, what can I combine? So I'm not combining 4m and 3m. I'm combining negative 4m and negative 3m. That's important, right? What is negative 4m plus a minus 3m, or negative 4m minus 3m? That is minus 7m. They're gone. I now have a 5 plus a 6, which is plus 11. Can I combine? Listen, this is important. Can I combine those two? I mean, the 11, can I combine them? Absolutely not. Are they identical? This has an m. Does this have an m? No, you can't combine them. This guy's a constant. Question. No, let's just write it out. Let's write this out. If I was to write this out, it would be, remember, they're each going to have their own sign. This is negative 4m and then minus 3m, is it not? Are those two negative signs touching? Are they touching? No. If I was going to be multiplying those two things, then it would become a positive. But I have negative 4m minus 3m. Those negative signs aren't touching. You don't turn that to a plus sign, right? There's no red flag here. Okay, you guys try a couple of these. Try this. Some easy ones. Okay, here we go. What you should have done is what? You should have grabbed each term, right? Grab each term. Can I combine anything here?
Yes.
What can I combine, Gigi?
2x.
So I have plus 2x plus 4x. What's 2x plus 4x?
6x.
And then I have a 6 out front. 6 plus 6x. Can I combine those two? Why not? Because they're not. Use math terms because they aren't like terms, right? You can't combine them. They're not like terms. Right? How many of you got that? 6 plus 6x? That's not enough. Did you make 12x? You combine non-like terms. Okay. What about this? A little bit different here. Pay attention now. Pencil down, Brad. Now they want you to watch. What's the first thing I should do? Circle them, right? Grab the terms. You will not need to do this for every assignment, circling these terms. But today you do. Right? I want you to circle the terms so that you get used to seeing them as a like term. Now that you've done that, is there anything I can combine? What can I combine? I can combine the 9m and the negative 2m. What is 9m minus 2m? Do you see what I'm talking about? This is important. Listen, this is why it's so important that you circle this. Some people might go 9m, or they might go like this. They might think it's 9m plus, and then 2m. Do you see what I'm saying? That's not it. That's why you have to grab each term, right? Each one has its own symbol. 9m minus 2m is 7m. They're gone. Now I have 2r plus r. What is r here? What's right in front of that r? What's right in front of it? Not a 0. There's not 0 r's here, right? If there was a 0, that would be 0 r's. 0 r's is just 0. They would put plus 0. What goes in front of that r? A 1. This is plus 1r. They just don't write the 1 because that's redundant, but that's a 1. If I have the variables p. If I have the variable p there, how many p's are there? 1. It's 1p. We just don't write the 1 because that's redundant, right? It'd be like me saying Gigi has the two most beautiful eyes. No, two beautiful eyes. No, she has 2 eyes, right? I mean, she has, you don't need to say the number in front. She has eyes. This you don't say. It's just redundant. If I have an x, I don't need to say 1x. It's assumed that x is 1, right? Does that make sense? So then, knowing that, even though that 1 is not written there, what is 2r plus r?
3r.
Plus 3r. 7m plus 3r. Can I combine those two? No, why not? They're not like terms. Does that make sense? Okay. Try another one. This is a good one. We'll see if you can get it. Okay, here we go. Okay, grab the terms, right? Everybody grabs their terms. Does it go like this? Is this how you grab the terms? No. Each one's got to have its own. The one in front is the one that has the invisible one, right? Okay. Can I combine anything?
Yes.
I can combine all of it, right? They're all p's. That's fine. Okay, so here we go. What is p? Well, what is in front of that p?
1.
A 1, right? If you need to, do the 1. What is 1p minus 6p? That's negative 5p. Does that make sense? That's negative 5p. Negative 5p plus 4p is negative 1p. Now, here's the deal. This is not wrong to put negative 1p. However, I'm going to mark it wrong starting maybe like Wednesday because we don't put a 1 in front of a variable. We just don't. That's redundant. Okay? It's assumed. So then what should it be?
Negative.
Just negative p. We don't put the 1 there. It's not that you're wrong, but I mean, what you're saying is that now all of a sudden you need to put a 1 in front of every variable. Every time you have an x, you have to have a 1 in front of it. Every time you have a y, you have to... No, obviously not. And so don't put a 1 in front of a variable. It's assumed that there's a 1. Make sense? Okay. Now we're going to get into something that is a little bit more... well, we used yesterday's distributive property a little bit. Let's look at this one. And I want you to simplify this. All right. Put your pencils down so you can watch and learn. Here's the deal. This is where you have to get to the point where you recognize something right off the bat. Does anybody see something here that just goes, boom, you see something you've got to deal with? Right, but can I do anything with these parentheses? Can I do anything with 3 plus x? Can I make that? No. So what do I need to do? No, what's it called? It's called the distributive property. Do you see the need for the distributive property here? Right off the bat, rainbow, rainbow. Do you see it? You have to recognize that. You have to get to the point where that just stands out to you. Because that's what you have to do right away. Does that make sense? I can't combine anything here until I'm done with that distributive property. Think about it. What's the order of operations? I have to do parentheses first, right? Do you see parentheses? I do. Can I combine it? Can I do anything with that? 3 plus x? Can I make that any better? No. Okay. So then after that, it's exponents. I don't see any. Do you see any multiply or divide?
Yes.
I do. The multiply is right here. There's one right here, but you can't do anything. 4 times x is just 4x. But I can multiply this, right? This is 3 times this. So rainbow, rainbow. Fix it. 4x. What is 3 times 3?
9.
Plus 9. And then 3 times x is plus 3x. Does that make sense? Now we get to the point where we can actually start combining like terms. Grab each term. What is 4x plus 3x? 7x plus 9. Can I combine the 9 and the 7? No. Did anybody get 7x plus 9? Okay, let's practice that one. Do this one for me then. Go... a good one. Watching. You're learning here. Okay, first thing. What do you see? I would say, let's say the distributive property, right? I would say, you look at that and you recognize that there's a distributive property right there. Here's the kisser. How many of you did 2 times 5? That's not true. Remember, this is a -2 out here. You should see that. It's right there, right? -2. So it's -2 times 5 is -10. So it goes 4x plus 3, -10, and then -2 times x.
-2x.
Makes sense? Makes sense? Now you grab terms again. What is 4x minus 2x? Do you see that? Which is 2x. 3 minus 10? Nope.
No, negative. Wait.
When you say 7, you're wrong. That's opposite. It'd be like if the answer was yes, you said no. Right?
I got 6x plus 3 minus
6x, what?
plus 3 minus.
Well, yeah, because you can combine the 3 and the -10. Right? And you have 6x, which means that you put 4x and then you added 2x. That's not true. So you didn't get here. When you did this, you put a plus 2x there. That's not true. It is -2 times x, which is -2x. Right? Makes sense? Let's do another one. Let's do another one. It's a good one. You're watching. Here we go. What do you recognize right off the bat? This is where you just need to scan the problem and go, oh, there's something I got to deal with. The distributive property. Right. So we're going to go rainbow, rainbow. Let's take care of that right now. Rewrite everything else. -10m plus 3. And now I have -4 times m. Do you see what I'm talking about? That's a -4 times m, which is -4m. And then I have -4 times a -2, which is plus 8. Right? Plus 8. That's the part you got to get right off the bat. You got to do that. Okay, now grab terms. What can I combine? -10m and -4m is?
-6.
No, it's -14. If I have -10 and I have -4, right? -14m. And then I have 3 plus 8 plus 11. How many of you got -14m plus 11? That's not enough. We'll do another one. See, these you got to be able to do. Okay, what about this? Here we go, watch. You're paying attention here. You got to learn how to do this. I mean, right? This is not, what do you recognize right off the bat? Distributive property. 4 times 7 is? 4 times -x? -4x. Okay, then minus 30 plus 4x. Everybody grabs their term. What is 28 minus 30?
-2.
Okay. What is -4x plus 4x?
0.
Do I put plus 0 there? No. What's the answer?
-2.
Do you see it?
Yes.
Y'all see it?
Yes.
I hope so. This is the kind of stuff that this is not like more difficult than you should be able to do. One last thing. When I give you things like this, 5m, another term you need to know. First of all, this is a term, right? All paying attention. Eyes up here. Eyes up here. This is a term, right? 5m plus 4x. Those are terms, right? Those are each terms. Anytime you have a number and a variable, the number that goes in front of the variable is called the coefficient. Coefficient. You just need to know that. The coefficient is the number in front of the variable. There are questions on here, so here's the deal. I want you to tell me all the coefficients to this problem right now, Lauren. I want you to tell me all the coefficients. What are the coefficients to this problem? What is the coefficients?
Negative 4
Negative 4 and
and 5.
5. Those are the coefficients. The number that happens in front of the variable is called the coefficient. What if I have this? Negative 4m plus 5x plus 7. What are the coefficients?
Negative 4 and 5.
That's right. It's still negative 4 and 5. What's this guy called?
And
He's called the constant, right? He's called the constant. If he doesn't have a variable, just a number sitting there, he's a constant. Make sense?
wait, so what are those called?
Coefficients. If you guys listen, everybody right now, look at page 76 and 77. Everybody's book should be open to page 76 and 77. Everything I taught you is right here, right? You realize that there are a lot of people that could go home and take this book home and not have a teacher and teach themselves how to do pre-algebra. You know why? Because they explain everything. Everything I just explained to you is right here on these pages. Do you understand what I'm saying? This is not a book of just problems. This is a book of explanations. And so here they are. If you ever have trouble with anything, first thing you can do is you can ask your parents if you want. If they can't help you, you can go back online and watch the YouTube video that I post every day. If you still don't get it, you can go back to the book. The book shows you how to do everything. Everything I just showed you is right here. You forget, what's that word called? Oh, right. Did Mr. Duncan just make that up? No, it's right here. They even highlight it for you in the book on page 76, right? It's all there. So there's really no excuse to not doing your work and being like, I don't really get it. It's fine if you don't. That's fine. But you have so many other resources than just, I don't remember how to do it. Coming back to me the next day and go, I didn't understand what you said. Well, then I'll ask you, did you rewatch the video? Did you ask your parents? Did you go online and watch Khan Academy? Did you check out the front of the book? Because they explain everything, right? Here's your homework. Page 78 to 79, 1 through 31.